Hi everybody. In yesterday's class we discussed about resolution of a vector. Okay, I think you might have practiced the worksheet also. Very good. In this session we are going to discuss addition of vectors. Right? Addition of vectors. So how to add two or more vectors, let us discuss now. Right, here addition of vector, let us see first geometrically how to add two or more vectors. Let us learn. After that we will see mathematically how to add the vectors. Suppose let us take two vectors a bar and b bar. Let us take a bar and b bar. Now the magnitude of vector A is let us take 2 meters, and the magnitude of vector B is let us take 1.5 meter. Both are acting in the same direction. We can see that both the vectors are towards east. Yes? Yeah. How to add these two vectors? When you add these two vectors, you will get again a vector physical quantity. Remember that when you add two vectors, we will get again a vector. Okay. Now to add two vectors geometrically, we need to follow two steps. The first one is the tail of the second vector should be joined to the head of the first vector. What is that, sir? Tail of the second vector should be joined to the head of the first vector. This is the first step which we need to follow. Right? See here, this is the tail of the second vector. What I am doing here is I am adding vector A to vector B. Okay. Now B is the second vector. So vector B tail is this point should be joined to the head of the first vector. Understood? So tail of the second vector should be joined to the head of the first vector. That means let me draw again vector A. Already we discussed that without changing the magnitude and direction, a vector can be moved anywhere within the same plane. So this vector B I am drawing in this way. Right? Now step 2 is I said already, when you add two vectors, we will get another vector. Okay. Now A plus B gives another vector C. Now how to draw vector C? The final vector can be drawn from the tail of the first vector to the head of the second vector. Okay. The vector which is joining the tail of the first vector to the head of the second vector is the resultant vector. Means this whole thing is the vector C. Okay, understood? So what is the magnitude of vector C? What is the magnitude of vector C? It is 2 plus 1.5, that is 3.5 meters, because both are acting in the same direction, so that we can add simply. Understood? So this is the magnitude of the vector C. What is the direction of vector C? It is towards east only. Towards east. See the vector C also towards east. Understood? So in this way one can add two vectors geometrically. Okay, no. Now let us see how to add two vectors mathematically. How to add two vectors. Now let us take vector A is 2i plus 3j minus 4k, and another vector B as I minus j plus 2k. Okay. Now I am going to add vector A and B. So here whenever you are adding, component of the vectors should be added. See, this is 2i is in the x component. Here in vector B, I is in x component. These two will be added. 2i plus I, that is 3i. Next, 3j is along y component. and here minus j is in y component. So these two will be added. 3j minus j, that is 2j. Okay, next plus minus 4k plus 2k. This gives minus 2k. Okay, so the vector a plus b is 3i plus 2j minus k. Understood? In this way, we can calculate mathematically addition of two vectors. Okay, so one can calculate the magnitude of vector a plus b. That is the resultant vector c. Okay, so the magnitude of vector c, that is equal to magnitude of a plus b is root over 3 square plus 2 square plus minus 2 whole square. That is equal to what we are going to get, that is 9 plus 4 plus 4. That's it. Okay, so what is the value? Root over 17. Root square root of 17 is the magnitude of the resultant vector. Magnitude of the resultant vector. Understood, everyone? Yes. Now let us see subtraction of vectors. Okay, x and y are the two vectors. They are acting along east. The magnitude of vector x, let us take as 5 meters, and the magnitude of vector y, let us take as 3 meters. Now I want to subtract vector y from x. Okay, when you subtract two vectors, again you will be getting a vector. So now the resultant vector I am taking as z. Z is equal to x minus y. That is equal to, so simple. Again you need to follow the two steps what we have discussed. Tail of the second vector should be joined to the head of the first vector. Okay, now here this is x and this is y, but what we are doing here, it is x minus y. So this can I write as x plus of minus y. Can I write or not? X minus y, I can write as x plus of minus y. But we know y only. How to get minus y? Yes, we learnt negative vector concept. So if I want to write the negative vector of vector y, simply I should reverse it. Okay, now this is minus y. Understood? Now x plus of minus y is equal to 5 plus, what is minus y value? It is minus 3. Then it is 2 meters is the magnitude of the resultant vector. So how to do it geometrically? Now I should keep the tail of minus y vector at the head of the x vector. Means see here, this is vector x and minus y vector is this. Then the resultant vector is drawn from the tail of the first vector to the head of the second vector. So this is our resultant vector. Understood? In this way we can subtract the vectors. Actually, subtraction of vectors is not defined. Here see what we have done, we have added two vectors, right? So for that purpose what we have taken, we have taken y as minus y. Okay, so in this way one can subtract the two vectors geometrically. What about mathematically? So let us take another two vectors, x bar as I plus j minus k and vector y as minus I plus 2j minus 4k. Okay, now I want to do subtraction of these two vectors x minus y. Let us take this is a vector z, that is equal to I minus of minus I minus of minus I, okay, plus j minus 2j. Next minus k minus of minus 4k. Yes or no? So what is the value? I. So it is 2i minus j plus 3k is the z vector. That means the resultant of the two vectors x and y, right? So what is the magnitude of this z vector? We can calculate very easily. Root over 2 square plus minus 1 whole square plus 3 square, that is equal to root over 4 plus 1 plus 9, that is root over 14. Understood? Right. So in this way we can add vectors and we can subtract vectors. Right, Nana? So here you may get a doubt. Sir, can we add a vector and a scalar? Can we add a vector and a scalar? No, it's not possible. Why, sir? Simple. Scalar have only magnitude, okay, but vector have magnitude and direction. Understood? Let me explain more clearly. Suppose I have 4 bananas and you have 2 bananas. Right, Nana? I have 4 banana and you have 2 banana. So what are the total bananas? Very good, 6 banana. Suppose I have 4 banana and you have 2 apple. Now can I add these 2? No. Okay, because these are fruits, but they are not same nature. They are not of same kind. Understood? So similarly, vectors and scalars are different physical quantities. So that's why we cannot add a scalar and a vector. Similarly, we cannot subtract a scalar and a vector. And one more thing, when you are adding or subtracting two vectors, those two vectors should belong to the same physical quantities. The two vectors should belong to the same physical quantities. Remember that. So we can add force and another force. We can add velocity and another velocity. Okay. So in this way, the two vectors should be of same. Right. So far we learnt how to add vectors when they are collinear. Means they lie on the same line. Now let us learn how to add if vectors are mutually inclined. Right, means they are non-collinear vectors. How to add we are going to learn. Here A bar and B bar are not collinear vectors. To add A bar and B bar we follow the procedure. Very simple. Vector B is slides parallel to itself such that its tail coincides with the head of the vector A. Then the vector drawn from tail of vector A to head of vector B represents the sum of vector A and B, can be denoted as C. Here we can write A bar plus B bar is equal to C bar, or it can be written as A bar plus B bar minus C bar is equal to 0. Okay. From this we can learn two important points. One is the minimum number of collinear vectors whose sum is 0 is 2. That means two number of collinear vectors are required to make their sum is 0 when they are equal in magnitude and opposite in direction. Okay. Next, second point is the minimum number of unequal non-collinear vectors whose sum can be 0 is 3. Right? Non-collinear and they are unequal in magnitude. Then we need 3 vectors to make their sum 0. Okay, Nana? Right. Next one, let us learn triangle law of vector addition. What is that? Triangle law of vector addition. If two vectors are represented in magnitude and direction by the two sides of a triangle taken in order, the third side of the triangle taken in reverse order represents their resultant in magnitude and direction. This is the statement of triangle law of vector. Okay, now I will explain this by taking a diagram. Right, see here, vectors A bar and B bar are representing the magnitude and direction by the sides of a triangle. right? The sum of vectors A and B is taken in the reverse order to represent the resultant in magnitude and direction. That is vector C bar. Actually, when you add two vectors, the resultant vector is drawn from the tail of the vector A to head of the vector B. Yes or no? Yes. Here we will be taking that in reverse order to represent its resultant magnitude and direction. Then we can write from the diagram A bar plus B bar plus C bar is equal to 0. Understood? Right, from this we can conclude two more points. That is, the minimum number of coplanar vectors whose sum to be 0 is 3. Understood? Right. Next point is the minimum number of non-coplanar vectors whose sum to be 0 is 4. Right, Nana? Right. If the triangle method extends to add any number of vectors in one operation, then it is called as a polygon law of vector addition. It is called as polygon law. So if vectors are represented by the sides of a polygon, then the resultant vector is the closing side of the polygon. In this diagram, A bar, B bar, C bar and D bar represents the sides of a polygon. If I want to add these all vectors, the sum of these all vectors is the vector E. It represents the closing side of the polygon. Clear, Nana? So in this way one can add vectors. So these are the today's concepts. Let us meet in the next video. In the description of the video I uploaded a worksheet. So after watching this video, for your practice I have given that worksheet. Download the worksheet from the description and practice it. Don't forget to subscribe my channel. Give a like to the video and share it to some others. By that, someone will get benefited. Thank you very much.